move to now our next speaker, and he represents our favorite organization, Ripon System, and Qasim Loan. The stage is yours.
Welcome. Hi, thank you. My name is Qasim Loan, and today I want to talk about advancing internet connectivity in Central Asia, the role of IPv6 uptake, ROAs, and ROVs. So when we talk about routing security, the core of it is BGP. BGP ensures that the packet traverses the networks that are configured, and it makes sure that the packet reaches the correct destination. However, we have a problem at the core of this protocol, that is, it was not thought with security in mind. It's built on trust. So to illustrate, let's look at a very simple example where we have 4 autonomous systems, and autonomous system 4 in this example originates a prefix P1. So all the other ASs learns the path to reach P1, and the traffic goes as normal. But what happens if there is another autonomous system which either due to malicious intents or misconfiguration announces the same prefix or a more specific of it? So in this case, we see a partial or a complete outage for AS4. So services or websites or domains that are running on AS4 will see an outage because somebody misconfigured a BGP session or a prefix. And this happens in real life, right? We have a very famous example for people who have worked with BGP, probably knows by heart, of Pakistan Telecom in 2008, accidentally hijacking YouTube's IP space. And the result was a global outage for YouTube, where traffic that was intended for YouTube ASNs was sent to PTCL, that is the Pakistan Telecom. So how do we prevent such accidents or malicious actors? We use RPKI. RPKI helps us mitigate both accidental and BGP misconfigurations. In essence, RPKI answers a very simple question. Is the originating ASN authorized to originate this particular prefix? It has 2 parts to answer this question. The first is ROA, which defines which ASNs are authorized to announce a specific IP prefix, and ROV, which is basically a validator. So when you receive an announcement, then you look at the ROAs and then you validate whether it's a correct announcement, or in case of an incorrect announcement, you reject that. And that way it does not go further. So after the RPKI era and some form of adaptation happens, we still see these kind of attacks. So it's not that they're completely eliminated. A recent example is Iraq, when it tried to block the Telegram services in the service region, and there was a BGP misconfiguration. But because there was ROV close to the networks that were announcing the incorrect path for Telegram IP address space, it did not go very wide. So Telegram did not have a global outage because there was ROV. A very, very recent example is from Cloudflare. Again, a misconfiguration. Somebody started announcing the Cloudflare 111 popular address, and then again, due to there was some level of disruption. So you can read the Cloudflare blog on it, but still it did not go as far, thanks to, again, RPKI, ROA, and ROVs in this case. Now, coming to our region, the Central Asia, we looked at Cloudflare data for BGP hijacks. And I kind of aggregated them for attacks and victims, and we do see some level of hijacks happening within the region. It's not as much as the other neighboring countries. But still, as I said earlier, it takes just one misconfiguration for a global outage. So now we go a little bit deeper in ROAs and ROVs. So looking at route origin authorization or ROAs, we have reached a significant milestone earlier this year when 50% of the IPv4 space announced is now covered by ROAs. So that means there is some movement, and I'm hoping that this number goes up and up as we move forward in time. In our region over here, we have few countries that are doing really well. So in this case, for example, Kyrgyzstan, our host, have more than around 85 or 88% of their V4 space covered with ROAs, and Turkmenistan is again covering most of their IPv4 space by ROA and almost everything on V6. The other countries have a room for improvement in here. So going back to Central Asian market, it's an interesting problem because when we look at the market concentration, it seems like market is heavily concentrated, which is not good for the competition, but in a way, it also offers an opportunity that is a few key players in this market can basically change the dynamics of technology adoption. Some examples over here, for instance, the Kyrgyzstan, or the two providers, Megaline and Kyrgyz Telecom, when they added ROAs for their V4 prefixes, we see the adoption went from like 10-15% to more than 80% now for the country. In Turkmenistan, it's just Turkmen Telecom that added ROAs, and it went from almost non-existent to almost now complete coverage. We see similar trends for Uzbekistan, Tajikistan. In Uzbekistan, Sarkor and Turon, when they added, then you see few jumps in the ROA coverages. And in Tajikistan, it's Zmobile. Recently, they added their ROAs for their IP address space, and you see already from 9% to 28%. Now moving on to the second part of RPKI, the route origin validation. So that's a bit difficult to measure who is doing ROV or not, because you, in a way, need a vantage point near to see if somebody, and have to wait for somebody to misconfigure to figure out if there are policies over there. But we use a data set, Rovista, which calculates the scores based on number of RPKI invalid prefixes that an AS can reach. We went for a more inclusive approach, where we classify an AS having implemented ROV if the score is greater than 0. So there is any activity on ROV, we are considering it to be compliant. And we also use to visualize this network centrality or AS hegemony. What it does is basically it calculates the common transit, so the most important transit networks in a country. And those are the ones for a collateral benefit needs to be the most important when it comes to implement ROA and ROV in their network, because they provide transit to various other ASs, and the closer you are to the source of a misconfiguration, the higher the chances is that it won't go far in the network. Unfortunately, the picture over here doesn't show much activity on ROV adoption in the region. So in this, the blue color shows the ASNs if they have ROV. We also have a lot of missing data. So it's possible that some of these ASs have ROV, but because again, it's very difficult to measure, we don't have data on those ASNs. But where we have, we see for Uzbekistan, few networks have ROV, but majority of them don't. Tajikistan, we also don't see much. Similar for Kyrgyzstan and Turkmenistan. So there is a lot of room for improvement over here. Kazakhstan, we see a few ASNs again where we have data that are doing ROV, but again, majority of the ASNs we don't see adoption on ROV. So now I want to move to the future readiness or IPv6 uptake in the Central Asian region. Given the size of IP address, we cannot count the number of V6 addresses. So to do that, we came up with a metric called IPv6 capability. And in a very simple term, it's basically the percentage of ASs in a country that originates IPv6 compared to the ASs that originates only V4 address space. So it kind of tells us how much of the ASNs are routing or originating a V6 address. It does not necessarily equate to adoption, but it is a first step, because if there is no origination of V6 in a global routing table, then yeah, there is probably nobody is using V6. So using that metric in our region, we see like on average around 18% of the ASNs in the region who are announcing V6 address space. To get another metric, we actually look at CDNs to see their traffic statistics on V6 adoption. Here we also see that there is a lot of room for improvement. because we see, for instance, Kazakhstan is 13 to 17% when you look at Google, Facebook, and Cloudflare for the V6 traffic that they are receiving. Iran is a good, as an interesting case, because for some reason, Facebook says 76%. I don't know if there is a different way, because the methodology to measure is not very clear for me how they are measuring V6 adoption. But Cloudflare, Google, and the capability metric is around 20%. So I think that's better statistics, but maybe there is something else to it, which I don't fully understand. So for understanding adoption level, we did conducted a survey 2023 from all the members. And these are kind of the results of why there is low adoption across the globe. So 46% are ensuring V4, V6 feature disparity is an issue, but large majority of the people also think that it's just a mindset and the knowledge gap. That is one of the hurdles for V6 adoption. For concluding the RPKI, I think it's looking at how it's moving. We saw very recently that White House announces a roadmap, which doesn't happen for a lot of internet technologies, for the US government to secure 60% of the advertised IP space covered under ROAs. And then earlier this year, FCC, again, a US body came out and they asked the operators in US to come up with BGP security plan, which includes ROA and ROV. So here we also see that policymakers can have an impact in terms of enhancing the RPKI adoption and potential to establish guidelines and timelines for RPKI adoption. And for IPv6, we do need policy initiatives and infrastructure investment. And I also want to mention that we have some courses to help if the knowledge gap is an issue. We have IPv6 fundamentals course in Russian on our YouTube channel. Please do watch. Alex did a whole series on understanding V6 fundamentals. And we also are having a training. So if you need more information, you can go to the desk outside. And please do join the training if you want to learn more about V6. Yes, that's about it. So question, comments. And
Да, вопросы у нас в конце, я напоминаю. Поблагодарим нашего спикера. Thank you very much, Qasim.